Hello Year 9, how are you guys? Welcome back to Mr. Chan's videos. How are you? I actually feel a lot better now from coughing, so hopefully this video recording will go pretty smoothly, okay? Let's finger cross. So today in Year 9 Maths, we will be looking at similar figures and area for geometry. So the topic today is perimeter and area of similar figure. So what happens is if we have two similar figures, so as you can see here we have two square at the bottom. When the two square is similar, they have similar proportion, we will be able to find their perimeter. If one is given and not the other one, we can actually just use the scale factor to estimate, no, to calculate it. So the keywords involved are similar figures. Okay, so we all know what similar figures are. If you don't, you have to go back and watch the previous videos. And perimeters, we know perimeters are the length of total length of the outside, okay, outermost section of the figure. And area is, we all know what area is. Area is pretty much all the total coverage of the inside, okay, the whole calculation of the whole circle, for example circle or rectangle. And scale factor, for last videos we know scale factors is equal to length of large figure over length of matching small figure. Okay, so that's your K, which is your scale factor. So perimeter and area of similar figures in general, when the side length and of a two-dimensional shape, so 2D shape, okay, not 3D, are increased by a scale factors, the perimeter increased by a factor of K. Okay, I will explain what it is. So just for example, if the larger one is increased, like if the size is twice as big, what you need to do is you just need to multiply the perimeter of the original one by 2, okay, because it's twice as big, and you will get you should get the answer for the perimeter of the bigger one without even calculating the whole thing. All you have to do is just multiply by the scale factors. And on the other hand, for area, okay, it is increased by K squared. So if it is twice as big, what you need to do is you need to square the scale factor. So that will be 2 to the power of 2 because it's twice as big, and then you square it will be 4. Okay, so 4 and then multiply by the area of the original one, you will then get the area for the larger and large figures without even calculating the area. So it shows here, so 5, if it is twice as big, you need to make sure you need to square the scale factor, so it will be 4. Okay, so it will be something like that. So that means if the area of the small original figure is 5, that means the area for the enlarged figure will be 20 centimeters, okay, square. Okay, so square as in because the area is squared up. So let's look at the first example. So here we have square A and square B, and square A has the side length of 2 centimeters on each side, okay, and square B, which has been enlarged, is 4 centimeters. So if we're gonna calculate the square A and square area of square B, this is what we're gonna do. So perimeter of square A is 2 plus 2 plus 2 plus 2, okay, which will be, remember they all have to be centimeters, which is 8 centimeters. Yeah, does that make sense? And for perimeter B, square B is 4 plus 4 plus 4 plus 4 centimeters, all of them, which will give you 16 centimeters. Okay, and area of square A is, we know area is length times width. So length there is 2 centimeters, width is 2 centimeters, so it's 4 centimeters squared. That's the area. For area of square B is actually again length times width, so 4 centimeters times 4 centimeters. Which is 16 centimeters square. Okay, so what that means here is, let's have a look at whether these rules apply. Okay, so I can technically don't have to calculate for the scale factor. I just need to, as long as I know the scale factors, I should be able to know the perimeter of square B and area of square B without even doing all these things. Okay, so let's find out the scale factor. The scale factor K is equal to side of the large one, so we're going to use that and compare to that. So always do the large one first, and it will give me 2, which means the square B is actually twice as big as square A. So from there, we know. So if I'm going to calculate perimeter of square B without doing all those 4 plus 4 plus 4 plus 4, what you need to do is the perimeter increased by a factor of K. All you need to do is 8 centimeters, which is, all you need to know is the original, for the original length, original perimeter, okay, of the square A, which is 8 centimeters. 8 centimeters, which I got it from here, and then you just need to multiply by the scale factor. So 8 times 2 is 16 centimeters. Look at that. Isn't that the same as that? So all you need to do is just multiply the original perimeter of the original square by the scale factor times 2, and you will get the answer. And for area, it says here area increased by a scale factor K square. So first you need to square your scale factor. So K square in this case will be 2 square, which is 4. Yeah, 2 multiplied by itself is 4. And from there, the area of the original square A, which is 4 centimeters square times 4. Okay, because we want to multiply by the K square, which is the scale factor times by itself, which will be 4. So 4 times 4 is 16 centimeters square, which is, there you go, which is that, which is what we have calculated earlier. So that is what it means. Okay, so let's do one more example so that you actually get a better understanding. So here we have these two triangles are similar. What are the scale factor? So as we know, scale factors is k equal to the length of the large one divided by the matching length of the original one, which is the small one. So so that we're gonna use that one. Okay, we're gonna use that. So original is 4 centimeters, and no, I mean sorry, the large one is 4, and then original is 2. So 2 times. Okay, you can actually use that one as well. Okay, it doesn't matter, it should give you the same answer, which is, and that is actually how you see if they are similar or not. You need to calculate scale factor on both sides. If they match, that means they're similar. Okay, just in case that question actually tricks you. So 12 centimeters over 6, that will give you 12 divided by 6 is 2. Okay, so there you go, scale factors is 2, that means twice as big. So from there, we can calculate the area of small triangle, which is length of triangle is actually, if you don't know length, it's actually half times length times width. Okay, so, or length times height, sorry, length times height. So from there, it's pretty straightforward. Is half times 2. Okay, length is actually, length is actually 6 centimeters, and height is actually 2 centimeters. So from there is half times 12 centimeters. Okay, 6 times 12, and half of 12 is 6 centimeters square. Okay, area we always need to square it. And from there, it asks, that's the area of small triangle. And for C, use the area formula for calculate the area of the enlarged triangle using the area formula for a triangle. So we're gonna use both. Okay, so first we're gonna just do the regular one, which is again area of enlarged triangle equal to half times length times height, and half times length here for the enlarged one is 12 centimeters, height is 4 centimeters. So half times 12 times 4 is 48 centimeters, and half of that would be 24 centimeters square. Okay, so area of a large triangle, if we use the regular formula, is 24 centimeters square. So like I told you, if we use the scale factor, area to scale factor, it will be looking like this. So the scale factor, remember, it increased by k square. Okay, and k square here refer to 2 square, which is 4. So if we're gonna use gonna find that area, so area of a large triangle will be area of the original, which is 6, times k squared, which is 4, and 24 centimeters squared. There you go. You got same answer for both. Same answer. It doesn't matter which one you use. Okay, so there you go. So in the future, both are quick. You can use both, but the scale one, that one can be used in tricky situations where they give you, let's say, the area. They give you the scale factor, and then they give you the area of the original. Okay, and they ask you to calculate the area of the enlarged. So you can literally just do it by multiply it straight away without actually have to go and find out the length and height of the enlarged one. Or it makes things a bit easier. So that will do for these videos. Hope you guys learned a thing or two. Remember these rules. Remember this one. In general, when the side length of a two-dimensional shape, 2Ds, are increased by a scale factor, the perimeter is simply multiplied by the scale factor, and the area is actually multiply the area of the original by the scale factor squared. Okay, squared. And write down any question you have, write down the notes. Actually, make sure you do that and ask me during lesson. Thank you for listening. Peace out. Bye.